What's the next conservative force we're going to hit? Let me do this example for you. We've got a mass on a spring. It's compressed some distance. And we move it around. Move the mass out to here, then back into here. What's the new energy of our mass? Here, let's do this. Let me do this. Let's start here. We start here. We compress the spring by some distance by moving along that path. Our spring now has energy stored in it. It's done a certain amount of work on the block, right? What if I had done this? What if I had taken the block and stretched it and then brought it back that way? Same work, because half of this time the spring would be doing negative work, and half of this time the spring would be doing positive work. And those cancel out, and so you end up with the same work. So the spring force is our second conservative force. So we come up with a potential energy term. We say the work done by the spring is going to equal negative the change in potential energy for the spring. And so what do we get at here? We say the spring potential energy is 1/2 kx squared because that was the work done by the spring, right? 1/2 kx squared. So that's the technique. Anytime you come up with a conservative force, that's the last one we'll see this quarter. Next quarter you'll see the electric force is also a conservative force. You'll come up with a potential energy term for the electric force. Work done by the electric force. Okay, so we've got some potential energy terms. Why do we call it potential energy? Because it has the potential to do work. If you have this object in a certain position in the gravitational field and we let go of it, the gravitational force will act on it, will do work on it, changing its energy. If we raise it up to a higher position in the gravitational field and we let go of it, the gravitational force can act on it over a longer distance, do more work on it, and give it more energy. So it has more potential, right, for the up here when we let go of it than down here. So there's more potential for the gravitational force to do work on it. So we call it potential energy. It's almost maybe a stored energy. It's energy that the object has. For the gravity, it's by virtue of its location in the gravitational field. For the spring, right, it's how much the spring is stretched or compressed, how much energy is stored in that spring and can do work on something if it's allowed to. So we can do a different approach with these problems, because what we're going to say is that the sum that we're going to use one of our big theorems in physics, and that is conservation of energy. And that the energy in a system can't be created or destroyed. It can only change from one type to another or be transferred from one object to another. So one analogy we use a lot is money. And we have a lot of different kinds of energy, right? Energy of motion. Now we're talking about energy because of a position in a gravitational field or energy stored in a spring, things like that. Well, we have a lot of different kinds of money, right? There's all different kinds of coin, all different kinds of paper, there's credit cards, there's checks, there's all different kinds of money. But it all does the same thing, right? Money gives you the ability to buy something, right? Energy gives you the ability to do work. So it all seems very different, seems very arbitrary, but it all is tied together. It all gives you the ability to do work. And if we were to lock the doors, make this room a closed system, then the amount of money in this room is fixed, right? And it might get transferred from one person to another, but it's not going to disappear or appear, right? The amount of money in the room is not going to change. Same with a system. If a system is isolated, it's sealed, no energy can enter or leave, then the energy in that system is a constant. It might get transformed from one type to another. It might get transferred from one object to another, but the total amount will be the same. Okay, that's a big theorem, an important theorem in physics, and we'll use that to solve this type, the one we did earlier, what we did with all the works, right? Found all the different work done on the object, the chapter 7 technique for solving a problem. This problem right here, right? The chapter 7 technique, find all the work done. Well, the chapter 8 technique is we just look at changes in energy using our potential energy terms, things like that. And I think you'll find it's basically the same thing, but I think you'll find it a little easier.